Welcome to the Explainer. Today, we're jumping right into an incredibly cool TEKS 8.2F math lesson. We're going to take a journey from abstract algebra straight into building strong, real-world foundations. So, let's get right into it.
Section 1. Strong angles, strong relationships. The foundation of perpendicular lines. Okay, let's dive into this. The source curriculum actually takes a pretty fascinating approach here. It mirrors math with human connection, using a famous quote from Proverbs 27:17. It says, "Iron sharpens iron, so one person sharpens another." Just think about how perpendicular lines create structure by, sharply changing direction. The whole idea is that people who positively challenge us help build a really strong, stable character. It's like a right angle. It's strong precisely because it meets head-on, creating this totally solid base. Now, you might be wondering, why does this actually matter? Well, understanding perpendicular relationships isn't just about passing some 8th grade math test. It shows sharp contrast and creates necessary structure. It's absolutely crucial for real-world architectural design, complex problem-solving, and interpreting everyday intersections. Honestly, it's a lot like knowing exactly who you need to surround yourself with to stay grounded. Section 2. The opposite reciprocal. The key to perpendicular equations. Now, what's really interesting here is the vocabulary. Let's define it clearly. An opposite reciprocal is the inverted opposite sign slope required to write the equation of a line that is perfectly perpendicular to another. I promise you, mastering this one single definition is literally the secret to unlocking every single perpendicular equation problem you will ever face. It's really that important. And this brilliantly illustrates exactly what I mean. Let's look at the original line, y equals 2x plus 1. The original slope here is just 2. Now, to get our perpendicular line, we need that opposite reciprocal. So we take that 2, which, remember, is really just the fraction 2 over 1, and we flip it completely upside down to get 1 over 2. Then we just change the sign from positive to negative. Boom, our new slope is -1/2. Flipping the number and changing the sign is exactly what creates that perfect right angle intersection. Section 3, step by step, finding the equation, a repeatable formula for success. Mathematical confidence really comes from having a reliable plan. So we are going to break down this abstract algebraic process into a rigid, repeatable formula. Here's the straightforward 3-step plan. Step 1, find the opposite reciprocal of the original slope, just like we practiced. Step 2, plug that brand new slope along with your given coordinates right into point slope or slope intercept form. And step 3, simply solve for b to complete your new equation. 1, 2, 3. If you follow these exact steps, you are totally equipped to tackle literally any line on the coordinate grid. Section 4. Mastering the math, applying the steps to real problems. Let's move to this one and see how this builds. Imagine we're looking at a whiteboard together. Example 1. Our setup gives us an original line of y equals 3x plus 5. And the target point our new line has to pass through is 0, 2. First, we clearly identify our original slope from the equation. Right there, it's 3. Now, what's that critical opposite reciprocal? We flip that 3 over 1, change the positive to a negative, and we get a brand new perpendicular slope of -1/3. All right, let's solve it. We just plug what we know into our y equals mx plus b formula. Our y is 2, our m is -1/3, and our x is 0. So we get 2 equals -1/3 times 0 plus b. Now, since anything times 0 is just 0, this beautifully isolates our variable b. So b simply equals 2. We put it all together, and that leads us straight to our final perpendicular equation, y equals -1/3 x plus 2. Let's level up a bit with example 2. Original line, y equals -1/4 x plus 1. And our given point is 2, 3. Okay, our original slope is -1/4. Now stop right there. Don't let that fraction scare you. Watch what happens. A negative fraction simply flips to become a positive whole number 4. Honestly, the math immediately becomes so much friendlier. So the crucial point is plugging it all in to solve. Plug the values into y equals mx plus b. We get 3 equals 4 times 2 plus b. 4 times 2 is 8, so 3 equals 8 plus b. To isolate that b right here, it requires us to subtract 8 from both sides. 3 minus 8 gives us -5, so our new y-axis intercept is -5, yielding our final equation, y equals 4x minus 5. Moving right along to example 3. This setup. Our original line is y equals 5x minus 7, and our given point is 1, -2. The original slope is 5. By now, reinforcing this opposite reciprocal pattern should honestly be second nature. Flip it, change the sign. Boom, our perpendicular slope is -1/5. Time to solve. We plug in our values. -2 equals -1/5 times 1 plus b. That simplifies to -2 equals -1/5 plus b. To solve for b, we just add 1/5 to both sides. Now look, ending up with a fraction like -9/5 might look a little intimidating at first glance, but I assure you the math rules hold perfectly stable just like a right angle. Our final equation stands strong. Y equals -1/5x minus 9/5. Section 5. Your turn to practice. Put your skills to the test. Okay, I strongly encourage you to pause the explainer right here, grab a piece of paper or a notebook, look at these 5 problems, and prove your newfound mastery. Test out that exact 3-step formula independently to find the new equations passing through these specific coordinates. You absolutely have all the tools you need to crush this for sure. Section 6. Education with morality. The ultimate intersection. All right, let's transition beautifully back from math to philosophy for a second. The Smart Academy Godly Learners series takes a moment to reflect on this really powerful quote, "Education without morality will hurt." The source argues that, what is the point of being smart and supposedly educated if you're continuing to make bad choices? Algebraic intelligence is an incredible tool, but moral character is what actually builds a successful, unshakable life. The curriculum connects this directly to Romans 8:6-7, noting that keeping a spiritual focus naturally leads to stability and a peaceful mind. Engaging with this kind of morally anchored content echoes the exact same unshakable stability of those perpendicular intersections we just mastered. So, as we wrap up today's explainer, I want to leave you with this lasting, provocative question. As you learn to navigate both complex algebraic equations and the sometimes challenging intersections of your daily life, will you choose peace of mind?